energy leader at Arup. Simon's background is a structural mechanical design and analysis of offshore structures for oil and gas and renewables. He has a passion for transformational applications of digital engineering and regularly speaks on the subject at events around the world. Simon is the author of the Digital Twin Maturity Spectrum. 1 year on from the introductory talk on National Digital Twin Programme, Simon is presenting an update for us. The presentation will cover why the National Digital Twin Programme started, what's been achieved over the past 12 months, and what the future holds for the National Digital Twin Programme. Simon is ably supported by 3 speakers who will provide a brief update on their NDTP in action projects. The speakers are Lawrence Oakes Ash of City Science Limited, representing the Southwest, sorry for constructing excellence with multi-organisation digital twin models for transportation. Nigel Moore of the University of Wolverhampton, representing CE Midlands with Stella. And last but not least, Brian Denby of Mission Room Limited, representing CE Midlands with AEC Construction Sector Control Rooms. The 4 takeaways from this evening's presentations are: 1, the link between the digitalisation and decarbonisation. Number 2, how the various professions within the built environment will be impacted by the Digital Twin Programme. 3, what to consider for training and developing your people. Number 4, the need for an organisational digital twin roadmap. So under Constructing Excellence, I'm delighted that these 4 good people have taken their time out of their very busy schedules to present to us this evening. So without further ado, it gives me great pleasure to introduce the first person to the virtual lectern this evening, our keynote speaker, Simon Evans.
Brilliant. Thanks very much, Elvin. And yes, really happy to be here, and hopefully this will be a quite informative update to yourselves. So Elvin's already introduced me, so I won't give any more background to who I am and what I'm here to speak about, really. But the key is this is going to be about 1 year on from the National Digital Twin Programme, sharing some of what we've done, where we've come from, and where we're going. So before I get into that, I'd like to really start my presentation with this slide. It's a slide I've used before if you've seen me speak, and it's a famous quote that some of you might have seen from Henry Ford, which says, if I'd asked people what they would have wanted, they would have said faster horses. And of course, here he's talking about moving from the horse to the automobile, which you can see from the great picture on the right. But what I really like about this quote, and why I think this relates to digital twins quite nicely, is what it talks about is education and the ability for us to conceptualize and also relay the art of the possible. And that if we aren't able to clearly articulate it and share that vision, it's often hard for many people to understand. And that's why the very mantra of what we're trying to do here in the National Digital Twin Programme is be quite clear and concise and explain everything in a way that can be digested and used by industry and by society as a whole. So with that in mind, let me take you back down to where this all started. So it all originated from a document that came out in 2017. Called the Data for Public Good. Now, this document by the National Infrastructure Commission set out 3 key recommendations, which ultimately led to the formation of the Centre for Digital Britain and the National Digital Twin Programme. These recommendations are the ones shown on the screen here. The first, of course, is to create a national digital twin, which isn't a giant digital twin, of course, of the entire UK. That would be a ludicrous notion. It's actually really an ecosystem of connected digital twins that will enable better outcomes for the built environment. The second part was all around creating an information management framework, which is really the infrastructure that will allow this national digital twin to communicate. So you could argue quite similar to the internet in how it functions. And I'll explain more about that when I go through my presentation. And the third is the creation of the Digital Framework Task Group, which is a task and finish group to help govern and make sure that the recommendations of the National Digital Twin Programme and the Information Management Framework are in the right direction. Now, the whole frame of this, and the reason I think Data for Public Good is quite a good title for it, is this is all about how we can give public good through data. So it's not for commercial gain in the same way that we might see other corporates do. It's all about us, society, and us flourishing. Now, the crux of all this is if we look at it and consider what this means, it means that the built environment and what's really in scope as part of this project is really the economic, social and national infrastructures that we see. All of these come together to create the built environment. Now, the interesting thing about this is what we see is between each of these layers as such, there is a relative amount of information and data exchange that occurs, but not maybe information data exchange across all these layers, and not really the systems of systems thinking that is desired and required in order for us to achieve and get to this vision of a fully connected built environment. Now, I appreciate I've already said quite a lot of complex language there and said digital twins quite a few times, but I haven't actually defined what they are. So let me go back and explain what that is. Firstly, what is a digital twin? Well, in its simple form, it is this. We have some type of physical asset or physical world, as it says here, and then we have some type of digital representation of that asset or that world that's developed to a level of detail proportionate to what you're trying to achieve and what the use case is. Now, what we know is that we have data that flows from the physical world to the digital world through some type of workflow or pipeline, and that this is in right time, not real time, because there's a common misconception that in order to have a digital twin, you have to have IoT sensors and real-time data. But in reality, it's all about right time, having data arrive at the right frequency based on what you're trying to achieve. Then when this data is in the digital environment, it allows us to derive insights, make decisions, prescribe what we're going to do next, and engage with stakeholders, which ultimately allows us then to shape the physical world and have these interventions which will help us change, improve, optimize, and monitor what we see. Now, this circle, physical to digital, digital to physical, is what makes a twin rather than just a normal simulation or model. And the concept isn't new. The earliest examples we saw of this was actually the Apollo 13 missions by NASA, where they used a term called digital mirroring to help bring the astronauts home safe. And since then, we've seen an explosion of this concept, maybe under different terms, in the aerospace sector, the manufacturing sector, and my domain, the energy sector, probably the last 5 to 10 years, and really in the last 2 years within the wider built environment. Now, why that's key is what we're seeing is this connection of physical to digital, digital to physical is becoming closer and closer ever more because of advancements in technology such as connectivity, storage, and compute. And that's making this connection between the two happen at a much faster pace than ever before. Now, of course, digital twins are really exciting, and a lot of people were talking about it. And if you were to Google it, you'd find loads and loads of articles and results, and sometimes quite a lot of noise. But I think the really exciting thing is actually when we look beyond that and start thinking, well, what happens if we connected digital twins together into an ecosystem? What would that mean? Now, what I mean by that, and using this simple graphic here, is let's imagine we had a simple train on the left-hand side, a digital twin of a train, and that would be great in its own right. You know, we can understand things about just the train, but the real power would come as if we connected the digital twin of that train to that of its tracks and its signaling, and having a share of information between those parties. But then taking that further and sharing the digital twin of the rail system, if you will, with the transport system and the aviation system, allowing that exchange between all the parties, meaning that every system can help interact and inform another system. So systems of systems thinking. Now, this ecosystems of connected digital twins is the essence of what the National Digital Twin Programme is trying to do. It's trying to create the facility for this to work, because of course, doing so really requires something central, something in most cases sovereign funded, that isn't going to be driven by a commercial gain, to put something in place that can be for the benefit of society. Now, this has been the journey we've been on, and the document that really kicked all this off after Data for Public Good and really helped solidify what digital twins mean is this one, which is something called the Gemini principles, which is the guiding principles for how you should develop digital twins that come and cover 9 things around the topics of purpose, trust, and function. Now, this is a really pivotal document that was released about a year and a half ago that led on to the later developments around what we see now. Now, of course, underpinning all this is the idea of how you can have information exchange between various parties, as I termed it, the information management framework. And what we've done is quite recently released a document called the Pathways Towards the Information Management Framework, which outlines how this will happen from a technical context. Again, this is drawing parallels with how the internet in reality functions. And this set out 3 core components that needed to be done. The first was the creation of a foundation data model, a consistent, clear understanding of what constitutes the world of digital twins. So it's an ontological model that can describe the concepts independent of the problem domain. So the metaphor here is language. This would be the grammar of the language. The next layer is the reference data library, which is the particular set of classes and the properties we want to use to describe our digital twins. So again, the metaphor in the language, again, would be the use of words. And the final part being the information architecture, or the integration architecture, sorry, which is the protocols that allow this exchange together. Now, with all that in mind, as we've gone into financial year 2021 to 2022, we've understood and prioritised these three aspects of the National Digital Twin Programme. The first is the creation of this information management framework, which is specialist-led and top-down standards in essence. And then the second component of this is the DT Hub, the Digital Twin Hub, which is practitioner-led, and it's the bottom-up standards. So the two coming together, the Darwinian and authoritarian approaches, if you will. And the slice underneath, which actually is probably one of the most exciting pieces, is CReDo, which I'll explain about in a bit, which is a demonstrator of how you can actually do this. It's all right just saying, great, let's connect digital twins, but until we can demonstrate it practically, it's going to be very hard to realize. And this is led by specialists and practitioners. Now, let's take each of these in turn pretty quickly. The first is around the information management framework, which is a developed open and technical, but also a non-technical shared resource that will enable the national digital twin. So it's the core component really, that without it, we can't really achieve what we want to. Now, if we look at this through a different lens, how we should consider it is this: in the branding or the use of the word of 7 circles of information management. Now, the idea of this approach, the 7 circles, is that it divides the information management space up into areas that are concerned with addressing separately but supporting areas of interest. And a theory behind this is that as you go down the different layers of this, the complexity and the audience which understand it becomes more specific. So, for example, the bottom circle of the stack, the core constructional ontology, is really quite specific to mathematicians, ontologists, for example, and very heavily domain specialist people. But as we step up through each of these layers, each one supporting the layer below it, it starts to become more understandable, more usable by the society and industry more widely, ultimately ending in this information quality management at the top layer. Now, why this is important, the 7 circles, is we need to address each of these circles as we go through, because each one has a core component to how we structure the information management framework. Taking that step further forward, the two other components is around what we term the FDM, so the foundation data model, and the RDL, the reference data library. These are the starting points for developing the ontology, so the language that describes digital twins, which we'll put together. And we did surveys back in November 2020, which then led to in March 2021, and you can see where it fits in the 7 circles in the top right corner, the approach to developing the foundation model, which is what we're now doing. And you can see there's hyperlinks there that we'll be able to share in the chat afterwards. And this has been another pivotal document which has taken us further forward to start to build out what this looks like. Now, going a bit more into the technical detail, and hopefully this is followable by us all, that if we look at how the information architecture in general works, and you can see where that fits in the layers as well, it's further up the 7 circles. It works like this, that the information architecture alongside the FDM and the RDL is really the third key technical component of what we're trying to do. It consists of the protocols that will enable and manage the sharing of data across the National Digital Twin Programme. So all the data exchanges are supported by the IA, the Information Management Framework, and they'll be referenced to and based on the RDL, the Reference Data Library, and the FDM, the Foundation Data Model. So the National Digital Twin Programme's Reference Data Library will be an evolving ecosystem of compliant libraries that link together and plug together to form what we would term the Foundation Data Model, where their data owners can then publish into this National Digital Twin according to these standards that have been set. And this information architecture will include microservices, in particular those that allow data transformation and validation of information to make sure that it's really compatible with the model in itself. And once it's published, there'll be a catalogue so you can understand what's there and understand how you can access it. Now, the next layer to that is the data owners themselves, where to specify the permissions of who can consume the data, which will be supported by the right legal and commercial arrangements. Because, of course, what this is about is not just giving access to everything to everybody. It's about having the data connected and accessible if you have the right permissions and authority to do so. Now, after this, and you can see there the authorization layer will allow people and data consumers to get the information. We have, after users have authenticated themselves, the ability for consumers to then explore the catalogue, and thanks to this discovery protocol, we have see the data sets and the digital twins that are available and then access that data accordingly, of course, having the right permissions. So quite a lot in that, and that diagram I know kind of says a lot in its own right, but really this is the core construct of what we're trying to do. Now, taking that again further forward to a document that we published a few months ago, it was this one, which is all about the integration architecture patterns and principles. And this really explores the three general architectural pattern options of how we can do this. So a centralized model, a distributed model, or a federated model, and how that can help us realize the vision of the National Digital Twin Programme. Again, important things of how we're going to structure this and how it can be set up for resilience. And the next slide is really around how these then and the information requirements themselves can be supported. And this is helping us to, again, a document that came out a few months ago, to work out how an integrated approach to information management can be created and how we can identify the decisions that need to be made around the information and the requirements for how they should be used and the models and processes accordingly. Now, all of these things, again, are pretty complex, but what this really revolves in and gets to is a core component that is now become a focus of recent months around the skills and competency and how we can really drive into this and build out and understand the what. So you can see the left-hand side there, the skills and competency framework, but also the how, the capability enhancement program of how in order to enable all this, we can put in the right things in place, the right change programs, the right training tools, self-assessment studies to build the capabilities to support all of what we've just described. Because of course, what this is, I've got digital twins are very exciting, but under the hood, this is actually quite a technically challenging task that needs to be addressed, not dissimilar to how when we look at how the internet functions in reality, that works. Now, with all that as that first component, I say, of the information management framework and the work we've done to date, the next slice is that what we've been doing over the last year around the DT Hub, or the Digital Twin Hub. So since we launched it last year, the Hub, which is really a collaborative web-enabled community where people can come together and share knowledge around digital twins, driven by the motto of learn by doing and progress by sharing, we've seen an explosion of organizations and members from all over the world. So nearly 1,000 organizations and nearly 2,000 members actively contributing to this community and taking part in events, case studies, research, for example, and contributing to our glossary, and also helping record videos that we can publicize and use to educate the wider society and the wider industry around what digital twins are. Now, the mantra I said earlier around learn by doing, progress by sharing is key for this because it's helping to disseminate and make the knowledge base around digital twins wider. And the other mantra around this as well is the idea of collaborate on the rules and compete on the game. And everything we're doing within the Digital Twin Hub and the wider National Digital Twin Programme is being done intentionally in the open, in public, so people can see and we can be very explicit about what we're doing so that we can help everyone collaborate on the rules, work together on those fundamentals, and then compete on the game, which of course is then allowing industry and the market to be set up to benefit from this marketplace that will be created. Now, within the work of the DT Hub and also the work of the information management framework, we started to map out what that looks like in terms of standards and how the standards can all come together that enable this, and had a pretty interesting survey that was done, and this is the roadmap that shows it, of how the standards have evolved or will have to evolve over the next couple of years in order to support all of what's being done. Again, the links to all these documents we can share afterwards. And this is really a key theme under the Hub and under all of the National Digital Twin Programme of what we can do. And taking that again further forward, the National Digital Twin Programme's Hub itself has a couple of key objectives for this year. The real four that we have there we like to talk about the most is firstly providing a window into the National Digital Twin Programme. Now, you would have heard in the introduction at the beginning, Elvin said that I host a call called the Gemini call. Now, the Gemini call, for those of you I can see on the attendees, some of you already join us, but for those of you who don't, it's really the industry stand-up where the National Digital Twin Programme itself, through this window you can see as the first objective, share what is happening in the programme and allow people to ask open questions and answers. This is open to all of industry and all of society as a whole, and if you'd like to be invited, please let us know. We'll be very happy to forward the invite. You can also register directly and access it directly from the Digital Twin Hub. The second objective is to really help the Digital Twin Hub be a knowledge centre, which I've already explained, bringing people together and they can learn by doing, progress by sharing, and along with that, bringing together the industry, academia and asset groups into a place where that knowledge share can happen between the various groups and sectors, which typically we wouldn't see much interaction with, and enabling through all this, the change management and outreach fundamentally, not only in the UK, where of course this is the main initial focus, but also into the wider international membership, of which we've already have 400 international members helping to connect up with wider programs. Now, those are the first two slices I mentioned earlier about what's happening, the information management framework and the digital twin hub. And you might recall that there was that thicker bar along the bottom called CReDo that I said was one of the more exciting things that's actually about demonstrating the National Digital Twin Programme. So CReDo, or Climate Resilience Demonstrator Project, as it's termed, is, as I say, to demonstrate the benefits of cross-sector information sharing and test the information management framework, the IMF approach, and how we can then inform its development and make sure we're doing what's required. So really following the agile principles of, fail fast, fail often, and making sure that we can iterate and really do this at a pace that will allow us to achieve this vision of a national digital twin in a relatively fast timeframe. So the CReDo project is a project that's being put together at the moment, and it's looking and bringing together three particular sectors. This is around the energy, the water, and the telco, or the communication sector, and understanding how we can develop a digital twin of the localized infrastructure that fits within these sectors. Now, the initial use case that we're looking to develop is the impact of flooding on the network and the system interdependencies between these two networks, energy, water, and telco, and how each one can help understand and react to extreme weather conditions and the effects of it because of climate change. Now, a big frame of this as well is seeing how we can start to pull this together, particularly this year, because of COP26 and the topical nature of what that means for nationally designed contributions. Now, within this, the digital twin will be used to inform the operations and capital planning. And it says here in real time, but we'll use the term right time, let's say, and enable right time responses to those extreme weather events caused by the climate change that we'll be seeing. Now, the objectives to this is really to present the compelling case for connected digital twins on the international stage, as I say at COP26, and to demonstrate the benefits of cross-sector information sharing. Because, of course, we understand that connecting digital twins together should intrinsically bring a huge amount of value, but it's actually really hard to articulate what that value is without doing demonstrators such as this. And, of course, then to test the IMF approach and help enable its development, and to then, of course, create a lessons learned mechanism and system to support the growing ecosystem of connected digital twins that are going forward and being developed. So that's a frame of what we've done over the last year and what we're focusing on this year. I think the key thing I'll reflect on, and maybe flip to this slide, though I'll revisit it later, is what next and how to get engaged. Now, the key for this is there is a lot going on, a lot of things that we'd really love to hear you and have you involved in. The first one I mentioned, of course, is the Gemini call, which is a way you can keep up to date with the pulse of what's happening in the program. But more generally, there's the wider National Digital Twin community that exists within the Digital Twin Hub, which you can visit there at digitaltwinhub.co.uk and click sign up to register. And of course, reach out to any of us at the National Digital Twin Programme or myself as well, and we'd be very happy to answer questions. So hopefully that gives you a bit of a flavour and a background of what we've done. That's come in just on time, which is excellent. I'll now hand over to our other speakers who will take you through some examples of where digital twins have been used in practice.
Well done, Simon. It's brilliant. Good stuff there. So quickly, a change of speaker up to the virtual lectern. Lawrence Oakes Ash of City Science Limited. Lawrence, the floor's yours, my friend.
Hopefully you can all see this, and I will time myself. So if I go over, do prompt me. So just about us, we're City Science. We were founded in 2015 to look at climate change, really using data and insight to help people get results in terms of delivering climate change. So the stuff that you showed, Simon, is really interesting from that perspective. I'm going to be talking about transport models, and so some of the work we've been doing with transport models. So the key things we're trying to do here are to look at the different levels of scale and runtime, because those are big problems. So to give you an example, some of the larger scale models that we use in the UK, they might take 2 weeks to get a real answer out. So once you've processed it all, and once you've kind of then converted it into the analysis that gives the user an answer. So that's a huge amount of time that's taken up there. There's huge cost to the transport models that we build. So a transport model might cost anything up from £500,000. So huge opportunity to really try to pin down some efficiencies in how we build and maintain those models. And then we also have this question of scope. So a lot of the transport models that we operate in the UK are very much roads focused. So we have some siloed questions, and applications are then limited by the operators. So can we use computers to actually expand this, how we deliver outcomes to people? So this is a brief overview of what our view of a digital twin is. I'm not going to go into this in detail, but I'm just going to pick out a couple of things that I'm going to focus on here. So the key things that we're focusing on are context-specific mathematical models. So many of the users that we speak to in energy or transport, they've already got these mathematical models that they're already using. And it's really important that digital twin is better, or at least as good as the current mathematical models that they rely on. So that's one of the key things that we've been looking at. The other piece is around model calibration. So this is really at the heart of how you pair those models to the real world using data. So what we wanted to create was a way to automate that, because that's one of the key reasons why some of these mathematical models, in particular transport models, are so costly to build. And the final thing I'm going to talk about is once you've built that, how can you use these models to actually give you much better decision support? So it's just an example of some of the decision support work we're doing. So the first thing is around scale and runtime. So we have a lot of range of different models. One of the key things we've done in order to help move between these different hierarchies is essentially create automation so that we can move from strategic to operational to local models, all using on same data. So it's a really kind of critical component to enable that seamless movement over different scales. Then we're also looking at how we can calibrate these models in a way that doesn't require people. So at the moment, all of the calibration is a manual process, hugely time consuming and hugely costly. So what we've been able to do, and we've actually had some great successes on this. So this is an example of a network, a transport network you'll be able to see in academic papers. It's a Sufuels network. So we've created a method that enables us to automate the calibration of that network. And we've also been able to apply that in the real world. So this sort of application means that we can save huge amounts of time and huge amounts of money, the order of, £250,000 in terms of the model build, in terms of how we can actually build these models and automate the process of delivering them. And then finally, once we've been able to build these models, then there's a question of, how can we actually use these to create better outcomes for people? And one of the key things that we're using here is generative design. So this is an example that you may have seen, which is the Sidewalk Labs Delve product. So some great opportunities to use generative design once you've created some models, just to explore the wide range of the huge kind of solution space that exists within infrastructure. So this can significantly reduce design costs. It can speed up the design process. It can reduce the risk of rework, and it enables people to clearly see the trade-offs between different design options. And I think that's one of the key things. I think it refers back to Simon's talk in terms of what the benefits you can get of linking digital twins together. So a great example of doing this would be linking transport and energy to understand the different design configurations for an EV network, for example. But this is an example where we're applying this. So we're applying this in district heat. Obviously, district heat is one of the ways in which we're looking to kind of decarbonize the heating sector. But essentially, we create a model, we calibrate that model, and then we can use AI, modern computing, to explore that model in great detail and propose to the user a range of different design scenarios with different capital costs, different CO2 benefits, so that we can get a much greater resilience in the way that we're designing infrastructure. So that was 4 minutes and 50 seconds. So I'll stop there.
Great man. Well played, Lawrence. Thank you for that. Really good stuff, sir. Really good. Next man up to the virtual lectern, please. Introducing to you, Nigel Moore. Floor's yours, Nigel.
Excellent. So can someone just tell me if you can see my screen?
We can see your screen, sir. Well, I can.
Excellent.
Anyway.
And I shall go. Okay, thanks, Elvin. So yes, my name's Nigel. I'm both a lecturer and a researcher at the University of Wolverhampton, and I'm here to talk to you about the Stellar project's journey towards creation of a digital twin for off-site modular housing construction. So I don't need to tell you guys about this, but there is a real problem with housing in the UK. In fact, we're facing an unprecedented housing shortage, and this shortfall just continues to increase year on year. On the other hand, it's widely acknowledged that modern methods of construction, MMC, including off-site manufacture of houses in factories, can greatly reduce construction waste, improve productivity, and promote the building of good quality, low carbon, affordable housing. So optimization here is the key, and I think optimization of the factory processes involved in the above could thus help maximize these benefits, and that's where we're coming from. And also help the sector, this is not to be sniffed at, this also help the sector to reduce its overall emissions and carbon footprint, which I think we can all agree is really important at the moment. So what is Stellar? So Stella is a UKRI supported consortium project consisting of industry and academic partners, and they're all there on the screen. And it's seeking to develop and offer social housing developers the tools and the business models that they need to provide affordable homes across the UK at the point of housing need. Now, that last point is really important. What we're not talking about here is creating a massive gigafactory in the centre of the country that ships out all these volumetric modules that get used wherever they need. What we're on about here is using a different model, so the hub and spoke model. So the way that we envisage this to work is we will centralise the complex and high cost design, frame, manufacturing and certification processes within the central hub, which just happened to be the totally modular factory. And then, and this is where it gets underpinned with digital twin technologies, SME operated spoke factories can then be set up at the point of housing need around the country. Thus, this obviously supports local economy and provides the opportunity to train and employ a local workforce, which no one's going to argue is a bad thing. But by applying discrete event simulation, each factory's performance can be regularly observed, analysed, and through a feedback loop that Simon's alluded to in his excellent presentation, can be developed and improved over time. So, discrete event simulation, I think it probably deserves a little bit of a brief description. What is it? So it's a technique for modelling and simulating complex systems. It's type agnostic. It doesn't care what you're simulating, and in our case, the input data is layout, process flow, and timings. This gets fed into a discrete event process model, which is simulated. But the cool thing here, and this is where I think it is key, is it enables us to run multiple what-if scenarios over and over again, just by tweaking the inputs. And this could be virtually. These optimizations can be tested virtually or within a feedback loop with the physical twin, which in this case is the factory. So data. So a digital twin starts with data, and in fact, without data, there is no digital twin, in my opinion. So the way we're approaching this is we're using the totally modular factory as a catalyst for the development of a process digital twin. And then this is going to be developed in stages. Initially, it's going to be a descriptive digital twin, and this will be created to mirror the actual production system implemented at the totally modular factory by collecting and visualizing production data. Now, this could be real, or in the first instance, it could be simulated. And thus, this descriptive digital twin is describing what happened or what is happening. So capturing time series data in this way relates to production events and material stocks, whether it's real or simulated, is an important aspect of the role of the Stella factory digital twin. And in fact, it will provide a really rich data resource on which we're able to more accurately model future workflows. Over and above that, aggregated data in this way will enable the development of analytical approaches over time and enable us to push the development of the tool towards that of an informative or possibly even a predictive digital twin, where we employ data science and machine learning to get more knowledge from the data. So thanks for listening.
Lovely. Well done, Nigel. Thank you so much. And thank you for talking, my friend. Thank you for talking. Okay, last but not least, Brian Denby, sir. Take the floor, my friend.
Okay. Can everybody see my screen? Everybody see that?
Yes.
is a company that specializes in visualization and immersive visualization. And we've already seen behind the scenes there's a huge amount of complexity to digital twins. What we're doing is coming at it from the other side and saying, right, how will people understand and interact with these digital twins in an intuitive way? So we've been around actually for about 10 years now, supplying immersive technology in various guises to the infrastructure markets, rail, highways, and recently construction. What we have always been trying to do is to put people inside complicated data in a nice, simple way. So the reason we're called Mission Room is the first system we built was a room that you stood inside and the data was around you. It's evolved over the years, so we've got a range of different displays now. And we started off by trying to grab 360-degree images of real sites. And this is what we do. We built this cube, we put you inside it, surround you with images of the real world. Then we moved into the BIM world and evolved the technology so that you could stand inside your BIM model. And obviously BIM models are quite complicated. Trying to understand them, trying to communicate them to people is difficult. But it sort of evolved our tools and skills. And we also got involved in simulation. And more recently, we started to get involved in dashboards. So this particular clip here relates to an Innovate UK project where we're building immersive control rooms that we can drop into real construction sites to enable them to visualize real-time data. So typically we're talking here about BIM models, real imagery, dashboard data, lots of different ways and lots of different sources to the data. But the key is that we're trying to allow you to interact with that data, to understand it in simple terms. Lots of different applications for this immersion. And again, going back to what Simon said earlier, the different use cases, digital twins aren't just limited to one thing. They can be used for all sorts of different applications. So we try and provide a framework in which you can run lots of different software, and we're not committed to one particular bit of software that's going to help with digital twins. So for example, we're showing here a range of different BIM systems running inside, whether it's 3D Repo, whether it's Revisto or Bentley systems. It doesn't really matter. It's about trying to understand this complex data in a simple and intuitive way as possible. And the real challenge here is to make that interaction with your digital model simple and effective. So as an example here, we've got a project that we're running on with HS2 where they're using BIM models to actually enhance site inductions for people now, using 4D technology where they can actually take people in who are new to the project and take them through a 4D scheduled simulation of how that project is going to evolve. So that's using BIM data as the starting point, but it could equally be real images of site. So other things we're doing here is starting to look at more involved 4D simulations. So here again, really complex behind the scenes calculations about how this project is going to be constructed and developed. And we're trying to provide a simple but intuitive front end. And that's a real challenge, trying to make it simple for people to understand when all that data behind the scenes is actually very complicated. The interesting thing with the Innovate UK project, where we're looking to apply it to real-time construction data, is the data isn't really there. It's really difficult to get up-to-date information out of a supply chain on a construction project. And so a lot of the digital twin issues are actually not the technology. It's going back to really simple stuff like how do we collect the data? How do we make sure that data is all in the right formats to feed into the digital models? So Mission Room, I'll finish there. Mission Room basically is a way to visualize complex data in an immersive form.
Wonderful. Wonderful. Are you okay? I hope you enjoyed that, my friend, because that was brilliant. Really enjoyed that. Thank you so much. Well done, sir. Just hold there, Brian. Last but not least, I've returned to the lectern by Simon. Simon will just give us a quick rundown of how you guys can get more involved. Thank you, Simon.
Let me reshare my screen and I will talk about it. This slide again. So I gave this a very quick update before when I was going through my presentation. Oh, sorry. You can see a bit of a slide there. There you go. The key is, how do you get involved? Because there's some great stuff happening. We just heard some really great examples happening there as well. And we'll be able to take questions and anything you would like to ask us at the end. But there is many forums and many methods in which you can engage. The first one I'll mention is the Digital Twin Hub. So this is digitaltwinhub.co.uk, the community which you can be part of, you can take part in, and you can glean loads of good resources and see the events, case studies, the research that's happening, the glossary, of course, you can contribute to, and loads of videos as well. And go there, register, sign up, take part. The second you can do is get in contact with us directly if you'd like. So the email's on screen there, NDT, which is National Digital Twin Programme at CDBB, Centre for Digital Britain.cam.ac.uk. Or of course, reach out to us on Twitter or LinkedIn or Facebook, whichever form you'd like. And the third is stay up to date with the pulse of the project. And this is the Gemini call. The Gemini call being industry's weekly stand-up, where we spend half an hour, it's never less, sorry, it's sometimes less, it's never more, and we quickly go through each of the work streams and give updates on what they are, have feature focuses, which are presentations from industry about things that are happening, and then take questions and answers, which is no hold bars questions to the program itself, where you can ask anything you want of the team. And that happens every Tuesday, 10:30 to 11. So of course we had one this morning, but hopefully you can join us next week. So those are the three key ways to get involved. And of course, we'd love you too. So please do get in contact. And back to you, Elvin.
Thank you, Simon. That was brilliant, by the way, Simon. Just very quickly, Simon, did you want to let everybody know that if they can't actually catch one of the Gemini calls, they are recorded and they can look later, playback time? Is that correct?
Absolutely. That's a really great point. So we record all of the Gemini calls. So if you aren't able to make them, then yes, they are accessible and you can watch them back or join the next week and hear the next update. But yeah, absolutely. Please do not worry if you can't make that schedule regularly. There are ways you can catch up afterwards.
Thank you, Simon. Simon, if you just hold your screen so you're on there and you're unmuted, could I ask Lawrence, Nigel and Brian to switch back on their cameras and also to obviously unmute my friends. Thank you, all of you so far. That was brilliant. I'm going to get going with some questions if that's okay. Rob Garvey, good man, Rob. So in your own time, have a think about this, guys. How relevant are the principles of digital twins to most in the construction industry? And he goes on to say, are most companies still failing to grasp the concepts of BIM, let alone apply them? So do it, feel free. That's a good question, especially because I love the bit we did mention about skills and competencies. Sorry. So take the floor, guys. What do you think?
I'm happy to give the kind of the program perspective and my perspective on that as a starter. That sounds good. So how relevant? I think it is exceedingly relevant. I would say that digital twins, and particularly connected digital twins, are going to be the next transformational thing for industry and society as a whole. Now, what I mean by that is we often hear a comparison between how digital twins and connected digital twins work and the internet, and that the conversations and work we're doing today are going to be as important for society as the conversations that happened 30 years ago when Tim Berners-Lee and his team standardized the internet. Now, what I mean by that is if we think of the social and economic and business ramifications of what the internet's brought, such as us talking now, let's track forward and think, what does it mean to have connected physical digital assets 30 years in the future? It's literally mind-blowing. It's going to create a whole marketplace we could never have conceived and unlock things that we see today, such as example, the world's biggest taxi firm, Uber, doesn't own any taxis. The world's biggest hotelier, Airbnb, doesn't own any property. And the largest firms in the world are all tech companies based on the internet. So that's why I feel that although this might feel hard to grasp and BIM maybe hasn't landed in the way we'd like it to because of the maybe its message, the adoption, various challenges we can go into that, The actual core construct of what a digital twin represents, the convergence of a physical and digital world, is probably the most paramount important thing happening today and exceedingly relevant. Would be my view. But yeah, love to hear comments from the rest of the speakers.
Thank
Yeah,
you, that's good.
Sorry, I was going to say, there's a real danger that we don't communicate digital twins and the value proposition well enough to people. You know, there's a potential that people make it more complicated, just the basic principle of it, and that people don't grasp it. And just like BIM is in concept very simple, cradle to grave, data passing all the way through, and yet there are so many people who want to make it complicated. So I think there's a real communication issue that is around the whole idea that has to be grasped.
Thank you, Brian. Good point. Chats, don't have to. Nigel, Lawrence, did you want to add to that or detract in any way, shape or form, sir?
I guess my view is that they're very high level. I mean, and I think that the devil is in the technical detail, and the devil is in these trade-offs. The devil is in the fact that you're going to have a diverse commercial supply chain that might refuse to interoperate, and that's something we see a lot. So I think there's trade-offs between interoperating with something which adds cost, you know. So those are commercial issues which I think always creep in, and I think that there's a challenge there as to how we enable that.
Thank you, Lawrence. Very good point, sir. Very good point. Nigel, do you want to round anything up? So don't have to, my friend. Just
Well, I mean, I have to say, I completely feel for the guy saying that BIM hasn't landed in the way that we hoped it would. But I think we need to keep moving forward. I think digital twins are the problem with the digital twin at the moment. It's a bit of a buzzword, and if you go on Twitter, everything's a digital twin, and we're in danger of this turning people off this really incredibly exciting and useful trajectory that we're on with these just by calling everything a digital twin. You know, people are holding up a 3D model and saying this is a digital twin, you know. So I think, yeah, I got a lot of sympathy with Rob there, but I think Simon's right. This is a trajectory. It's almost unstoppable that this is going to happen. I think we need to grab it by the horns and ride it, for one of the better terms.
Actually, building on top of what Nigel said there, a key thing I kind of in part touched on in my narrative, but not maybe as enough, is that I mentioned the digital twins aren't new. No, this isn't a new thing. They've been around for 40 years plus. It's just now technology enables the reality of it to be realized. The other key thing is digital twins are not, I say not, here to replace BIM. Many people think a digital twin is the next evolution of BIM. It's not. Fundamentally, BIM, or information management, is a core thing you need in order to achieve the vision of a digital twin, and therefore it's part of the same story. So it's not like, oh, the people who have been aligned to BIM say, oh no, what's this new thing's coming on? It's taking all our credit. No. They're part of the same narrative. One requires the other. They're all trying to address the same thing, just technology, and you could say a buzzword that's more attractive in boardrooms has meant that it's got a bit more traction.
Can I just pick on that really, really quickly, Simon? Because that's really interesting. Dave again. Good to see you again, David, albeit virtually. Just wanted more of a comment, and I think you're all going to agree, but just for a minute. Great to see the phrase digital twin being used in the correct way. Yeah. A lot of companies are using this phrase as a bit of a buzzword. I think it's important to understand that BIM is a process, not a model or a design, and that BIM alone isn't working with digital twins without any data. Is that a fair comment, chaps?
Yeah, I think so. Yeah.
Yeah, I think it comes down to it. Data is everything. I think you mentioned it in your presentation. You know, without data as a starting point, it's very difficult to have anything that is meaningful following on. And certainly our experience is in the construction sector, getting that data and that from real construction teams at the moment is very, very difficult. So that needs to be brought up as the technology evolves. The processes to manage that data and collect it need to be much more rigorous than they currently are.
Excuse me. Can I just pick up next up? I'm a huge fan of the digital twin, and I'm a huge fan of data. I think it's fair to say, just want to give us a quick overview, guys. The construction phase, as it gets called, in the field of play. Is it fair to say that you will see as soon as possible, actually, digital twin making an impact on decisions in the field of play while we are constructing. Digital twin can have an enormous positive impact on the actual construction process. Would that be fair to say?
I'd say so. I'll add something first, and then I'll add a bit more frame around it that I think would be quite important to share. That as we mentioned then, is in some of our conversations a second ago, that it's been heavily hijacked and it's hype cycled. It's all over the internet. If you were to Google the word digital twin now, you would see the top 50 results would most likely be large companies, service technology providers with very large marketing budgets, of course, that can elevate the ranking. The key thing that we think is helpful here is that often a digital twin is perceived as a product or a technology. Like, I can buy a digital twin. Now, that's not really true, because fundamentally, as we've said, a digital twin is actually more an approach and a methodology, and it's a way of working, of connecting physical and digital assets together, which is underpinned by data throughout the life cycle. So you could say a digital twin is just leveraging data correctly through the life cycle to enable these benefits of a connected physical digital world. And therefore, considering it as a methodology rather than technology, absolutely is going to impact field of play, and it's going to absolutely impact construction phase, because it's about how can you use data to inform decisions and make and enact those decisions as you go in right time, not real time, based on the use case you're trying to answer. That would be my opener response to that.
Thank you, Simon.
I totally agree. And just I'd layer on top of that, though. I was quite interested, Brian, you talking about the difficulties in actually getting data out of the traditional construction process. And I think for me, this is the elephant in the room at the moment, and it's something that we're kind of going through ourselves a little bit. So I think, yeah, there's lots more conversations to be had. There's lots more hearts and minds to be won over. And I think there's a lot of, within the DT world, there's a lot of talk about not making the same mistakes we made with bin washing.
Well, I think there's another point here, and that is actually how you calibrate these models, and I think calibration is something we don't talk about enough, right? Because I know you mentioned the sort of the time series data, but are you calibrating, your predictions over the next week, over the next minute, you could get different accuracies over those different time periods. So calibration and that science around that is key to making these accurate predictions. So that's kind of goes to the heart of the matter of how we pair the digital world to the physical world, but we will get different accuracies over different time frames. And then I guess to pick up on the comment in chat around generative design, I mean, my view of this is digital twin exists. You want to get to the point where you've got the most accurate model possible over the time frame that's relevant to you, and then you trying to create these what if analyses. I know there were some other examples of what if analyses, which is really a kind of a decision support system. Generative design for me is a support system that helps you make those decisions downstream of having a really good model. And what's great about that is that it's a demonstration of how you can show linked models. So you could have a model that links carbon and transport and cost and all the different components, and see your trade-offs against those elements.
Excellent. I think you actually answered. Thank you so much for that, Lawrence. I think you've answered this, because this is from if I just very quickly, if I say your name wrong, I'm so sorry. Ilnaz Asharaya, thanks for a great presentation. Can you please explain where is the position of generative design in relation to digital twin? Lawrence, I think you said it there. Did you right? Am I right?
Yeah, I was reading that question and trying to answer it.
Yeah. Well, I think you did bloody well, sir. Well done. Well done. Right. Yes, digital twin is a proper noun. Simon, could you just
I mean, I threw that in there in jest, in part.
That's cool. That's
My
cool.
personal view is a digital twin is not a proper noun. It's a concept. It shouldn't be capitalized, and we see this ISIS throughout. An article come out, digital twin, as if it's this proper noun. No. So I just threw that out there to say I'd love to get. Maybe we can ask the audience to put a like or a crossface. I think there's a crossface if you agree or disagree with my statement on the chat window. That'd be interesting.
Yeah, well, we've all got pronouns now, so I think that's a damn good thing. Well played. Well played. Very quickly, Rob Garvey. God bless you, Rob. If digital twins are more about the approach to managing data, who should be leading the wider application of digital twins? What should say main contractors be doing? Great question. Great question. What do you think, chaps?
I think it's such an early stage. You know, our Innovate UK project, we have a main contractor there who's got lots of subcontractors, and just coming back to that, managing the data, making sure the data is accurate, up to date. It's about revising their processes with a view to be enabling digital twins going forwards. You know, and I think we're really in the early stages of this. Hopefully it'll accelerate quickly, but you've got to get that data right, and they need to get their processes right.
I think this is one where we'll probably need to watch the aerospace industry or the production industry, where they're consolidating data from multiple components into a single product. They're likely to be leading in terms of that, I suspect.
Absolutely. And I'll add on to that as well, that I completely agree. And I think we need to also understand who is going to be the ultimate owner of the data, and why that's important, of course. So take aside privacy and ethics part, is that we know that data is an asset. Everyone talks about that. You know, is it the new oil or is it the new asbestos? As a bit of another interesting question there. But the other interesting thing I think is really important to realise is that we know that accounting standards are trying to understand at the moment how you value data, and they take 5, 7, 10 years to update. So we could really see in 5, 10 years or so that companies will be required on the bottom line or in their financial reporting to report the value of their data. And therefore, on asset owners, let's take a large scale Highways England or Network Rail, you know, huge amount of capital infrastructure. They're going to have an onus on them to really understand the value of their data and what that means. And therefore, as contractors and us as a supply chain, of course, we can be custodians of it as it goes through, but like we would hand over the physical asset, it's plausible we would hand over the digital asset as well. And there's a conversation to be had there around how, up to that handover point, we manage that data. And I don't think we have the answers yet, but it's definitely a conversation to be had.
Chaps, I think you've been absolutely brilliant. Thank you, everybody, for your questions. Very, very quickly, just before we actually wrap, so if you guys just hold for a minute. First and foremost, very, very quickly, number one, our next event is Tuesday, the 6th of July, starting at 6 p.m. And our guest speaker will be Alistair Reisner of the Civil Engineers Contracting Association, tell us all about the construction playbook. Number two, would you please respond to the feedback email that Anna Kelly shall send in the next 24 hours. Well done, Anna. We do everything we can to use your comments to continually improve our product and service to meet your needs. Many thanks in advance. So to round up, a huge and incredibly grateful thanks to our hard-working London Construction Excellence Management team, the largesse and technical wizardry of the team at SIAD, who co-produced this evening's event, plus your good selves, everybody, for participating this evening. Thank you so much. Many, many thanks once again to our wonderful guests, Simon, Lawrence, Nigel, and Brian. Thank you, guys. You've been absolutely brilliant. Really, really grateful for your time and your effort. Ask you back next year, I think. Great stuff. Last but not least, good night, everyone. Look forward to interacting with you all again in 4 weeks' time. And viva out of lockdown. Thank you, everybody.
Thanks. Bye.
Thanks.
Thanks.
Cheers, chaps.